Hello and welcome. My name is Kevin Payne, and I am here with my colleague Chad Lee. And we're going to discuss the book Research, Design, and Counseling by Paul Hepner. We're going to go through a couple of chapters, Chapter 7 and Chapter 8. I will take Chapter 7, Validity Issues in Research, the Heart of It All. And Chad will go over Chapter 8, Population Issues, Who We Study Matters. So first off, to draw valid conclusions, the researcher must design a study that minimizes the potential of alternative explanations for the study's results. So we're going to take a look at 4 types of validity and the different threats to each of them. We will list all the different types of threats, but we'll go into detail on just a few of them. So here are the 4 different types of validity: statistical conclusion validity, internal validity, construct validity, and external validity. The first one, statistical conclusion validity. This refers to the degree to which the researcher has come to the correct conclusion about the relationship between variables. So I've listed all the different threats that are possible here. And what I'd like to do, for those of you who might be studying for your comps, I'm going to have a couple of examples listed from different ones of these threats and a multiple choice selection that you can choose from. And I will give you a couple of seconds in between those slides to think of what your answer might be. You're welcome to pause the slides in order to come up with the answer before moving on to the next one. So our first example: some students fill out a survey in class. Other students decide to wait and finish it at the beach during spring break. So is this range restriction, extraneous variance in setting, unreliable treatment implementation, or unreliable measures? So what threat is being shown by this example? If you chose extraneous variance in setting, you would be correct. Obviously here, the participants are completing their treatment of the assignment in 2 different locations, and this can have an effect on the variable that could change things in the research. So to counteract that, these extraneous factors should be accounted for and addressed through research design or statistical procedures. So our next question: John surveys 7 students about cafeteria food quality at his university and sends his findings to administration. What threat is this potentially? Heterogeneity of units, phishing and error rate issues, inaccurate effect size estimates, or low power? So what threat do we have here? Yes, of course, we're dealing with low power. We have a very low sample size, and that makes it insufficient to detect the true effect. So to counteract this, to minimize this threat, you can conduct a power analysis to determine adequate sample size. Our next question: Paul is excited to research the effects of music on toddlers. He plays different kinds of music in a preschool classroom over several visits, but he's not really sure what he thinks the effect of the music will be on the toddlers. So what kind of threat is this? Unreliable measures, phishing and error rate issues, range restriction, or heterogeneity of units? Yes, we are on a fishing expedition here. In this error, someone is conducting many statistical tests on a data set without a specific hypothesis. And so our friend here didn't really know exactly what he was looking for, trying to find something of significance. To solve this error, specify a hypothesis for the statistical tests or adjust significance level for multiple tests. So those are a few. Let's move on to internal validity. Internal validity refers to the degree of certainty with which one can make statements about the existence of a causal relationship between variables. And there are several of the internal validity threats listed here. So let's take a look at another example. My experiment group is from an inner city school, while my control group is from the suburbs. Is that selection threat, history, attrition, or regression? And it is selection. In this error, there are significant group differences that exist prior to treatment due to selection method. And the way to fix this error is by utilizing random assignment when possible. A TV special on depression was aired during an outpatient psychoeducational program geared towards reducing depressive symptoms. Is this testing, regression, history, additive, interactive effects? Which threat would this be? History. Yes, an event occurred during the treatment and may have impacted the results, skewed the results of the test. To minimize this risk, you may use 2 groups, or you can shorten the treatment period and isolate participants. Sue truly believes that she is an extrovert, and after taking the Myers-Briggs temperament inventory 17 times, she finally scores as an E. Is this maturation, attrition, testing, or instrumentation? Which threat would this possibly be? Testing. Due to taking a test multiple times, the practice may affect the outcome results. Especially since she was wanting to be an E, she may have answered some of those the way that she thought they would work out in her favor. Use alternate forms to measure the variable, or you may use 2 groups to account and adjust for changes due to testing that will help against this validity threat, this internal validity threat. Thirdly, the third one, construct validity. This refers to the degree to which the measured variables used in the study represent the hypothesized constructs. There are many here. We'll go over a couple of them. Women filling out an inventory are not sure if spousal abuse includes verbal abuse. Is this inadequate explications, experimenter expectations, construct confounding, or monomethod bias? Which threat is shown by this example? Yes, inadequate explications. In this threat, there is a lack of clarity with operationalizing a construct. To avoid that, you can conduct a careful, rational analysis of the construct's important or essential components. Dr. Neumeier uses his first-year students to test his new theory on test anxiety. Before administering their first exam, he strongly touts the benefits of his new method. Is this novelty and disruption effects, treatment diffusion, construct confounding, or experimenter expectancies? What threat did Dr. Neumeier do in this example? Yes, of course, it is experimenter expectancies. Dr. Neumeier consciously or unconsciously affected the results through how he communicated and interacted with the participants. The way he could minimize this threat is by making the purpose of the study ambiguous to experimenters or blind experimenters to treatment conditions. And lastly, we come to external validity, which refers to the degrees to which the causal relationship is generalizable across units, treatments, outcomes, and settings. So we see in these 4 areas here, they can cause a threat to the validity. We see under characteristics of persons, it could be a difference in gender or ethnic backgrounds, or schools, classrooms, it could be public or private school. It could be different treatments that happen. It could be in a clinical trial, or it could be something that is done in the community. Different outcomes could play a role, whether it's a self-report. Someone may take a Beck depression inventory, or it may be that the outcome is assessed by other measures, such as a psychologist who would diagnose someone with bipolar or a major depressive episode. Different settings can have an effect, such as a hospital. It might be a private practice, in the schools, or a mental health clinic. So those are some of the possibilities of threats that can happen to a research project. And now I'm going to hand it over to my colleague Chad to cover Chapter 8.
Thank you, Kevin. This is Chad Lee, and I'll be covering Chapter 8, Population Issues, Who We Study Matters, in the Research, Design, and Counseling text. A few things that we'll cover in Chapter 8 include population issues. These are defined by Heppner as the numerous complexities involved in selecting participants and generalizing the results based on the data collected from those participants. We'll also look at sampling theory, defining the target population, creating the participant pool, the selecting of participants, establishing validity, and determining the number of participants, as well as external validity and population issues, including factorial designs, and examining generalizability across populations. So, moving to sampling theory, this involves taking a portion of the population to study. So we have the population that we are wanting to get some research about and learn some more things about. And so in order to do this effectively and well, we're going to take a portion of the population, which is going to represent our sample. Sampling theory provides the foundation for understanding the process and the implications of selecting participants for a particular study, as we see in the Heppner text. It's very important, this chapter hits on this a lot, that we want to avoid the bias as researchers. The research obtained from the sample that we take should apply to the population. So we want that sample to represent the population that we're studying. If not, the sample is considered bias. And for a good example of this, you can turn to page 167 in the text. So then the question is, if we are all wanting to be good researchers, how do we fight against being biased? And that answer is random sampling. What is random sampling, and does it always represent the population being studied? Well, unfortunately, or fortunately, however you look at it, random sampling does not always represent the population. Random samples are samples in which each observation in the population has an equal chance of being selected. This right here is just a good a figure on page 169 in the Heppner text. It's how sampling is conceptualized for a hypothetical post-test only control group design. And so you'll see at the top we have our population that we're being studied through random selection. We get our sample right here, and then they both go through our control group design here. One side gets the treatment, we see the outcome. The other side gets no treatment and the outcome. Obviously, and then we compare that with our null hypothesis. So this just takes it from the population being studied all the way through the treatment, and we'll see the importance of random selection in getting our sample. So target populations. So, you want to select participants for your study. Well, the first step, we have to define the target population. So some examples of this might be diagnostic category, gender, ethnicity, age, sexual orientation, country of origin. Then we look at heterogeneous populations, individuals that are not similar to one another, and then homogeneous populations, similar or of the same. Heterogeneous populations are more generalizable, and homogeneous limit ability to be generalized. So those populations that are not similar to one another are more generalizable than the opposite. So after we get the first step of defining our target population, then we're going to identify the group of people to study, so our participant pool. Once we get that, we're going to select the participants to participate in the study, and it is best to use random selection in this because it's another step to avoid being biased in our research. So Heppner talks about the good enough principle, and so it goes into detail on page 173 in the text, but just a brief overview. So since random selection does not usually happen in research and counseling, non-random samples can have characteristics such that generalization to a certain population is reasonable. So we're always shooting for getting as random as we can. But sometimes this good enough principle makes it to where it's still generalizable to the population and can still be good research. Numbers are important. So the more participants that we have equals a greater probability that the sample represents the population. You'll see this on page 176. So then a follow-up question to that is, well, how many participants do we need? So on page 177, he says to answer, there must be an elementary knowledge of statistics. And we'll get to that in a later portion here. So external validity and population issues. So external validity equals is the generalizability of findings across persons. So we want our study to be generalizable across persons. We want it to represent our population well. Designs need variables in order to make this generalizability. So we got to add some variables in there, some controls, things that we can use within our study to make our research generalizable to this population and other populations as well, to kind of see what research we get. So status variables can be added to create factorial design. Factorial designs that represent relevant persons, settings, or times can increase external validity or the ability to generalize across persons. This is on page 185 in the Hepner text. This also allows for examination of independent variable and variables related to persons, settings, or time. So that is a very, very brief overview of external validity and the importance of our research having external validity with the populations that we're working with. And so that was my very fast overview of Research, Design, and Counseling, Chapter 8, Population Issues, Who We Study Matters. Thank you, Kevin. Okay, so I'm going to be covering Chapter 8, Research, Design, and Counseling in the Hepner text. In this chapter, we're going to look at population issues. Who we study matters. So a few things that we'll cover here in Chapter 8. We'll look at population issues, and those are defined by Hepner as the numerous complexities involved in selecting participants and generalizing the results based on the data collected from those participants. We'll also look at sampling theory, such as defining the target population, creating a participant pool, selecting participants, establishing the validity in the absence of random selection, determining the number of participants. We'll also look at external validity and population issues, such as factorial design to study external validity and examining generalizability across populations. Next, we'll go to sampling theory.